Hello and welcome to the Swine Disease Reporting System. This is the report number 90. My name is Guilherme Cesar here at the SDRS studio.
Hello, my name is Giovanni Trevisan of the SDRS team.
Hello, Daniel Linhares, also with the SDRS team.
And today we're going to cover the findings of the SDRS for July 2025. But before we go to the findings, today we have the pleasure of having here as a guest Dr. Maria Peters join the SDRS podcast. Dr. Peters was trained as a veterinarian and researcher and has been working on mycoplasma for over 2 decades. She's currently an associate professor at the University of Minnesota, where she leads research on the diagnosis, epidemiology, and control of infectious swine diseases. In today's episode, Dr. Peters will discuss with the SDRS team the trends of mycoplasma hypopneumonia decreased activity that we have in the swine industry nowadays, based on the diagnostic data that we have in the project that is providing some evidence of successful control and elimination of this pathogen. Welcome to the SDRS podcast, Dr. Peters.
Well, thank you for having me. It is always a pleasure to talk about mycoplasma, which is a topic that I really love, and especially important to talk about elimination and like seeing those trends on negativity. So this is a very special discussion.
Thank you for joining us, Dr. Peters, and we're looking forward to that discussion. Before we jump into that, Guilherme has some updates about the detection of pathogens that SDRS for the month of July. Guilherme, can you walk us through what we are seeing during the month of July?
Yeah, Giovanni, move to the report itself to our first page, that is the PRRS virus detection. Finally, we have a decrease in positivity for this specific virus that right now it's decreasing in all age categories. So we have the overall positivity going to 19%, finally below 20%. And in the winter market category specifically, we had a major drop in positivity in this month, going to 29%, which compared with last month that we had 39% of posted submissions. But besides of this good news, Giovanni, we had the second quarter of the year that corresponds from April 2025 until June 2025. We had the worst detection in the winter market category for PRRS virus historically. Since 2013, we didn't have a high detection in the finishing sites as we had specifically in 2025. Just to highlight this summer that we are having an atypical activity for this virus. And it was not only the PCR data, but also the confirmed tissue diagnosis. There are the cases analyzed by the diagnosticians to see the lesions and everything in these tissue cases. And then we have the record of cases in the second quarter historically in the whole database, just to see how PRRS virus activity was really high in this specific month. And it was not only these two databases, but the sequence itself called our attention that the L1C.2, this specific variant, it's already established as the second one most detected after the L1C.5 in the United States in 2025. But what caught our attention is that in the last report, we mentioned about the first detection of this variant in North Carolina that was never detected before. And since then, we have more 7 detections in the same state, which call our attention for how this variant is being detected in North Carolina. And the 7 specific sequences that came from this state were from 2 breeding herds, 2 nursery sites, and 3 growth finishing sites. Moving now to the enteric coronavirus itself, is a quiet activity and is expected for the summer. For July, right now, we have a decrease in all age categories, and even the one that we are calling our attention, that was the facilities category. So every PCR case that comes from vehicles and packing plants, finally, this one decreased as well. So mild activity, a really low activity for this specific coronavirus, Delta and also PED. And moving now to the mycoplasma case, percentage of positive submissions, we had also in July right now the lowest percentage of positive submissions for mycoplasma in the sow farms. Historically, we just had as low positivity in June of 2012. So a lot of years passed that we had as low positivity as we are having before, even confirm this trend of decreased positivity of mycoplasma. And when we look to the confirmed tissue diagnosis itself, again, from the ISU VDL, the case that the pathologists analyze and see the lesions. Also, we had the second quarter with the historical lower number of cases. In the first quarter itself of 2025, we have the lowest number of cases in a quarter historically, and right now we have the lowest second quarter in history. So that's great news for Mycoplasma that we are having the decreased detection of this specific pathogen, supporting these trends of elimination from Mycoplasma in the US. And then when we move to the PCV2 and PCV3 data, it's impressive the overall positivity of PCV3 that we are seeing right now. So a lot of positivity for this specific pathogen. The overall positivity of PCV3 right now is around 68% of positive submissions. Just for you to have an idea, PCV2 is one of the pathogens that we have in the database with the highest percentage of positive submissions, and PCV3 is having 30% more positivity compared with PCV2. It's a super high detection for this pathogen. And when we look to the sample types that most of these positive cases are coming from, the majority of them are processing fluids and followed by oral fluids, which decrease a little bit our attention because we are not seeing a lot of tissue cases or abortions, for example, coming from these specific cases, but still a lot of detection, and something might be going on in the field that we need to investigate. And finally, moving to the confirmed tissue diagnosis, not a surprise, PRRS is still like on the top of the pathogens detected in July. But when the summer months start to come, as we are having right now for June and July, we see an increased number of cases of E. coli. And when we look to the report, is the third pathogen that is most detected, most seen by the diagnostician in this confirmed tissue diagnosis cases for these last 2 months, compiling data for June and July. And that's are the highlights for July 2025, Giovanni.
Hey, thank you, Guilherme, for sharing all of these highlights there. So, Dr. Peters, let's dive deeper into the Mycoplasma pneumoniae discussion now. So, we have been seeing about the last 2 decades, a lot of work done in the Mycoplasma pneumoniae, lots of publications about elimination there. Why do you think that just now we're seeing that there is a movement in the swine industry to successfully eliminate these pathogens from the swine production?
Okay, so there are many, many parts to that question that you asked, right? And I would start saying that maybe in the last 20 years, we have seen this changing in the United States, but elimination of Mycoplasma pneumoniae has been around for a longer time. You know, in the late 80s, the Europeans started doing the eliminations, right? So this is not anything new, but it is something that we have applied more recently. And I would say that, you know, it's been a little bit of a combination of many things, right? But it's been a generation of new knowledge, improvement of diagnostics, learning together, you know, as a community, the swine community, like, you know, the information is generated, people are using it, and then you see what happens in the field, then you get more information from that, you adjust the methods, and then you redesign things based on the information that you're getting. So it's like we've been feeding ourselves during this process. One thing is that, you know, 15 years ago or so, we learned that the persistence of Mycoplasma was finite, the way that we looked at it, right? For many years, we were looking at that persistence, and it was longer than any study we have done. And then we did one study in which finally, you know, 8 months after the initial infection, the pigs were, you know, being negative, right? So that was a very good piece of information to be able to go to the drawing board and think about designing methods that were something that we could adjust to the conditions in the US. So that was, you know, a very important piece. Now, you know, over the years, we have learned more and more, and we know that that's not, you know, written in stone. It's like things change, and especially with co-infections. More recently, we showed that, you know, in PRRS, that goes beyond those 8 months, the 240 days, right? So, you know, learning every step along the way has been a lesson, and the swine community shares, and that's super important because then what we learn helps others get there. So I would say, just trying to summarize my answer here, is like, it's not that we are only seeing the success now, but it's like we are seeing more successes because we have better information that has allowed us to apply the methods in a better way, and then being able to get to the goals that we have set up from the very beginning.
Thank you for all of that education there, Dr. Peters. And you mentioned a lot about the time that is needed to eliminate the mycoplasma from the herd there. Can you touch base a little bit in what else we need to get rid of this pathogen? And I want to pick your brain if there is still some gaps that we need to fulfill to be more aggressive for the elimination of Mycoplasma rhamnosus from the US swine industry.
Okay, so I have a wish list, right? The things that I would like to know to be able to get this, to get to do this in a better way. But I can think of two things that are super important to me. First of all, what are the drivers of pathogen persistence? What are the drivers of that bacterial persistence in the respiratory tract? If we knew better, what those drivers were, then we would know how to do things and tackle the pathogen in a more effective way. So I think one of the limiting factors to do more and more eliminations is the fact that it's a very long process, right? And it requires a lot of effort and time and resources. And when you think about 8 months, we're talking about a very long time, right? And if we knew how to shorten that period, then that would be ideal. We will be able to complete the eliminations in a shorter time, and that will be more efficient, and it will be better for everyone. We are not there yet. I know that, we have tried in many ways to take shortcuts or circumvent things, right? But we haven't been able to come up with a protocol for Mycoplasma elimination that is shorter than the persistence of the pathogen. So that's one thing. I think if we knew that would be great. The other thing is that we don't really know the virulence factors for this agent. And we have been, working blindly with the tools we have, but if we knew that better, then we will be able to design better tools to be able to do elimination in a more effective way.
Mm-hmm. It's coming back a little bit to that 8 months that we're talking about. Can you walk us through again the dynamics of that infection timeline, and also come with the gilts, right? With the importance of the gilts, and how does the gilt population fit in the breeding herd scheme as we talk about elimination plans?
I'm glad that you're asking that, because in reality, that's central to Mycoplasma elimination, right? And we know, a pig gets infected with myco, and it takes this long time for them to eliminate it. And when we need to understand this part of the epidemiology of the agent to be able to know how to effectively do elimination programs. And if you think of a pig that gets infected early in life, and that is a commercial pig that goes to market, it's like once it gets infected, when it's very young, it's going to go to market and it's going to be positive for Mycoplasma. So there is not much that you can do because of the cycle, the production cycle, right? But think of the animals that stay in the herd a longer time. And then we're talking about the sow farm, right? Like those sows that are going to be there for a long time. Then you think 8 months, it's a long period, but it's not the entire cycle, right? So because of that, knowing that is central to be able to know about the dynamics of the pathogen within a population. And then the gilts come in, and it's key to know how to manage those gilts, because they are, just think about the health of those animals usually. And this is something, that's very good within the swine industry. We try to be healthier and healthier each time, right? But then we're bringing in gilts that are very healthy. And if we're in a situation in which the farm is positive, is endemically infected, right? Those gilts are going to be naive, they're going to be totally susceptible, and they're going to get infected if that's what is going to happen. So because of that, we need to protect them to be able to, face that that infection that is going on at the farm, or we need to work as well with the sows not to infect them. So we need to work with two different populations that can that are going to interact and that can affect each other. So because of that, it's like, knowing the circulation in the sow farm is key, but also protecting those gilts from that infection. When we cannot really, protect a gilt that is coming, a negative one coming into a positive herd completely, right? Then what we have to do is expose those gilts and let them recover. So by the time that they enter into the farm, they are no longer shedding, they are not posing a risk to the baby pigs and the rest of the population. So the elimination programs take all that into account. That's why it's not like, very easy to implement them. There's a lot of, logistics that goes into it, but it's because we are, working on the epidemiology of the agent.
Gotta make sure that 8 months timeline start in both the gilts and the sows, right? And another key question we receive is when we think about sequencing for epi purposes, right? For the PRRS virus, it's pretty, I don't say pretty straightforward, but almost a no-brainer. You do an elimination, you sequence the R5 or the whole genome, and then you compare it. If it's within a few percentage points, you call it the same. If it's not, you call it a different virus. How are we with those molecular sequencing for Mycoplasma to help people understand if they succeeded or not? Should they detect a Mycoplasma in the future?
Okay, so yeah, we do sequencing for Mycoplasma, not at the same extent that, it is done for other pathogens. And I mean, like you can tell, for example, if the variant that is circulating in a farm when you collect that sample is 100% similar to what you had before, and then you can, infer, okay, this is a failure of the elimination, not a different infection. But to tell if something is different is a little bit more complicated, right? And it will be arbitrary. Several years ago, we wrote a review paper, a group of, experts on Mycoplasma, and then we had conversations like, can we establish a cutoff to tell what is different and what is not? And within the group, I mean, like we all agreed that it would be arbitrary, and we didn't really have the information, the knowledge to be able to say this is what we are looking at and what we should take as the cutoff. So what I'm saying with that is like, I don't know, is it 98, 97, 96, 99? Like we don't really know where the cut is, but you can tell if something is exactly the same or not. We have seen over time that when you sample in a farm, you see a little bit of change. Even if it is, the same variant that may be circulating, you don't get exactly 100% similarity. So you can get a little bit of change if you sample long enough. That's something that is not unheard of for Mycoplasma. Many times we think viruses change very much, but bacteria don't change at the same rate. That's true, they don't change at the same rate, but there is change. And especially in the sequencing that we do for Mycoplasma, we look at one specific gene. And like I said before, we don't know the virulence factors, right? So there is one gene that has been selected for this, but it has areas that are that have some specific repeats, and then different variants will have different numbers of those repeats, and we don't really know at this point a lot about what it means, when those repeats are longer, more or less. So there is a lot to be learned. But the more we do, and the more we submit samples and build trees, that's going to be better, right? Because we're going to be able to make better comparisons. So I think for sequencing, at the end of the day, you are as good as your trees are. And for Mycoplasma, we don't have many trees with many branches. So yeah, we need more information. We need more submissions to be able to get to the point that we can make more of those inferences based on the trees. But it is a tool. that can be used, and is really important to know how to use it.
All right. Can you remind the audience the gene that
It's a P146. That's the gene, and I would say in the main laboratories in the US, that's where we're going to be seeing that, in the veterinary diagnostic laboratories. For research, we have done different analysis and around the world, right? Different people have done different analysis, but I think at the diagnostic level, this is the only test and that is available for sequencing.
Thank you.
And Dr. Peters, since we start to talk about the elimination protocols right now, we know that we don't have a single recipe for every farm, right? Every farm has its own particularities to apply an elimination protocol for Mycoplasma. But so far, based on your experience and what you are seeing in the field, what do you think is the most effective protocol, and which one that has the higher success rate for eliminate this pathogen for the farm, for the sow farm?
Okay, I think if you take depopulation and repopulation aside, right, that will be, you know, like the method that will have the highest success rate. Of course, if we take that one aside and then we compared what we use in North America, herd closure and elimination and whole herd medication, right? We have done comparisons for, I don't know, many farms. I would say over 15 years of data from Dr. Paul Jeske, who has been, you know, doing so many eradication programs in the US. And we have seen that there is a difference, that the programs that incorporate the whole hair medication tend to be a little bit less successful than the ones that do the herd closure. Okay, and I think, you know, when you think about the pathogen and dynamics of infection and all that, it makes sense, right? That when you are trying to make sure that all the animals are on the same page, and then you start the clock, because it's not just, you know, starting to count the dates and starting the elimination program, but you need to make sure that they are all infected and exposed, right? They develop disease, they recover, and then you are playing more with the dynamics of the pathogen in the population. When you do whole herd medication, you are using less of that dynamics, and then you're putting more weight on the treatment per se, which we know is not going to be able to clear the infection, not able to clear Mycoplasma pneumoniae. It can decrease, certainly, you know, the bacterial load and infectious pressure, but it may not be able to clear that at the end. So we have seen at least a 20% difference in the success rate, with herd closure being more effective.
Oh, that's amazing. And just a follow-up on that, how often do you see the vaccines, the Mycoplasma vaccines, being used in these elimination protocols? And for you, what is the importance of using vaccine or not using the vaccine?
Vaccines are very important tools and have been part of, you know, especially the herd closure and medication method includes vaccination as well, quarterly vaccination, even though it's not part of the title, right? To me, it's something that we need to keep in mind is that we need to be clear on what to expect, right? The vaccines are not going to protect completely an animal, but they are going to be very helpful on trying to keep, you know, all those animals at the same level, sort of, just to say it in a way. And then it can help even, you know, even though it's not like significantly that we can see that in studies, but we can see numerically that it helps decrease transmission. So vaccination really has an effect on what we're seeing as, you know, at the herd level for infectious pressure. And I don't think that using vaccines, you know, will bring something negative, you know, like to the elimination program. I can only think of the positive things that you can see, positive effects of using the vaccination, even though we need to be clear that they are not going to control the problem completely. Great tools. They're available everywhere. And as long as we know how to use them and what to expect, then we will be okay.
Awesome. Well, one more question while we have you here is, here in the US, it's pretty common to have site ones or breeding herds segregated from the growing pigs, but we do have some exceptions. And the model of having nurseries or finishers within the same farm as the breeding herd and be pretty common in other countries. So what are the particularities of eliminating mycoplasma in such complexes? With
That's that's important to mention, Daniel, and especially like in Latin America, right? I go quite a bit to other places, and in Latin America you see that situation, which is more similar to, I don't know, maybe the farms in Europe, right? Like you see those farms that are not segregated production systems that are set up that way, and it becomes a little bit more complicated, but there are the beauty is that there are different protocols that can be adapted to the different situations in type of facilities. So like you were saying earlier, there is no unique recipe that you can use to do elimination of myco. When you have pigs in a farm, farrow to finish, then think of the partial depopulation methods that are used in Europe. Maybe those will adjust better to that situation. They're not that easy, to be applied, and especially if the farm is a little bit larger, smaller farms, it works better. But definitely there are different protocols that can be applied. Maybe you have to be a little bit more creative and rent some places that you can take those younger animals, to those farms and trying to eliminate in the south farm. It takes a little bit more of logistics, to say it in a way, but it is doable as well. And there is a high success rate as well with a partial depopulation method.
That's awesome, Dr. Peters. And just for the end of the podcast right now, any final remarks, any final considerations that you want to give to the swine industry in this podcast?
Sure. Today we're talking about elimination, and that's a topic that goes to my heart. And I want to make sure that people know I am aware that this is not something that can be easily done. There is a lot of time, effort, resources that goes into an elimination program. But we are known, as a swine industry for wanting to have healthier herds, and we are also known for being a group in which we measure what we do, right? So the more you measure, what mycoplasma is costing you at the farm, then the more convinced you will be that this is something that you need to do. And there are ways in which you can quantify, like the potential benefits and the cost of the program and all that. So if you go through that exercise, then you will see the benefits and the potential that you have when you do an elimination program.
And that's it, guys. That was an amazing episode. I would say that was a class in mycoplasma elimination here today. I hope you have enjoyed the episode. Thanks, Dr. Peters, for joining us, and see you guys in the next episode.
Well, thank you for having me.
Thank you.
Thank you.